There are three forms for quadratics: vertex form, intercept form, and standard form. Today we're going to talk about intercept form. Intercept form is a factored version of your quadratic equation, meaning it's going to give you a product. It's called intercept form because it's easy to recognize your intercepts directly when looking at the equation. Quadratic functions have symmetry, which means x-intercepts will also have symmetry. X-intercepts will be equidistant from the vertex. The vertex is halfway between the x-intercepts. So we will take those x-intercepts, add them, and divide by 2 to get the x part of the vertex. To get the y part of the vertex, we just plug in what we got for the x part. Instead of calling it x part of the vertex and y part of the vertex, I still like to use the terms h and k, even though h and k are not in intercept form. There's not a literal h or k in here. Our first example will be to find the x-intercepts and vertex of the parabola. Then we'll graph, state the max or min, which would be the y value, state the intervals of increasing and decreasing, and the domain and range. I notice that I have a product, which means I'm in intercept form. My intercepts are p and q. Because the original graphing form is in x minus p, x minus q, p will be positive 2 and positive 4 in our first example. That means our x-intercepts written as points will be 2, 0, and 4, 0. On the x part of the vertex, again, I like to call it h, is halfway between those intercepts. To find the y value of the vertex, we will plug in 3 into our function. I know this isn't function notation, but I'm just going to say y of 3 as if it is. That just helps me stay organized. Let's simplify. 3 minus 2 is 1. 3 minus 4 is negative 1. 1 times negative 1 is negative 1. So h is 3 and k is negative 1. The x part of the vertex is 3 and the y part is negative 1. All we needed was the vertex in order to graph. Let's graph the vertex and use a to help us find our rise. A is equal to the number being multiplied here in front of our product of x's. So in this case, a is 1. The rise pattern is 1 unit away, we rise a, and 2 units away, we rise 4a. So if a is 1, we're just going to rise 1 unit and then 4 units from the vertex. So centered around the vertex, I'm going to go 1 unit to the right, and then we'll rise 1 unit. 1 unit to the left and rise 1 unit. Then 2 units to the right, we'll rise 4 units. 2 units to the left of the vertex, we'll rise 4 units. As you can see, 2 of those points are our x-intercepts. Let's go ahead and find the domain and range. Domain of all parabolas is all real numbers. X can be any value between negative infinity and infinity. But our range has a restriction. Our quadratic does not use all y values. Our quadratic either has a minimum or a maximum at its vertex. This parabola opens up, 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 up forever and ever into the positive direction. So this one will have a minimum. The minimum occurs at the y value of the vertex, which is negative 1. The minimum is at y equals negative 1. Therefore, the range goes from negative 1 up to infinity. A parabola is increasing for half of it and decreasing for the other half, and that's dependent on whether it's opening up or down. So this parabola is increasing from our vertex x value to positive infinity. So from 3 to positive infinity. And this parabola is decreasing from negative infinity up to 3. For intervals of increasing and decreasing, I'll always put parentheses so I don't have to think about it. And there's our graph for a quadratic in intercept form. Let's try another one. Begin by finding your p's and q's. P equals 1, but this one's a plus 3, so p could equal negative 3. But there's also an algebraic way to solve for that. Remember that on the x-axis, Remember that any point that is on the x-axis has the same exact y value. The y value of any point on the x-axis is 0. So, to find your p's and q's, you just need to make the y equal to 0. Let me show you the algebra for that. In Algebra 1, you learned zero product property, that if a times b is equal to 0, then separately we can solve by making a equal to 0 and b equal to 0. Therefore, x minus 1 could be equal to 0, and x plus 3 could be equal to 0. When you solve these for x, you will get p and q. This -1 does not give us a solution because it is not a linear factor. It is a scalar. A linear factor meaning there's an x to the 1, but a scalar is just a number that's being multiplied. Write the x-intercepts as points. Let's use p and q to find the vertex. H, or the x part of the vertex, is equal to p plus q over 2. We can solve for k by plugging in the h value into the original equation for x. This is basically a -1 times a -2 times 2, so k is equal to 4. That makes our vertex -1, 4. Because a is -1 here, our rise when we move 1 unit away from the vertex will be -1, and after 2 units away from the vertex will be -1 times 4, so -4. Let's graph. Moving 1 unit to the left and to the right, we will then rise -1. Moving 2 units to the left will rise -4, so go down 4. 2 units to the right, down 4. And look at that, our x-intercepts can be seen as part of our 5 most valuable points. Determine the domain and range. Domain is always -infinity to infinity, but this one, do we have a maximum or a minimum value? Because this parabola opens downward, it goes forever and ever and ever negative in the y direction, down. So our lowest y value is -infinity. But it does have a maximum y value that is allowed. That would be the y value at the vertex, 4. That means our max is at y equals 4. We have an increasing interval now to the left of the vertex and a decreasing interval to the right of the vertex. And here's example 2. Let's try number 3. You have a fraction as your value of a, and you'll also have a fraction as your value of h. Pause and try to do this one on your own, then play to check your answers. And that is intercept form and some more characteristics of a quadratic.